welcome back everyone to SpaceConneX Space Show episode 59, Sustainable Living in Space and the Future of Food, Materials and Energy Consumption. Quote, "You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete." End of quote. Lucky full minister. Humankind will immigrate to space for exploration, mining, education, and living. However, we cannot carry a lot of products and materials for a sustainable, long-term lifestyle in space. For this reason, we must think sustainably by designing and preparing everything to be sustainable in order to sustain life in space. Sustainability includes consumption, recycling, eco-friendly systems, and multi-use items. In today's episode, we will present examples on why sustainability is important for the space industry, how to design in space for life on Earth and its implication on space economy, as well as the future of food, materials, energy, and consumption. So when the show is over, our esteemed speakers, Ms. Fanam Bakley, she's a space architect and partner at Nonfiction, dialing in from San Francisco at 6 a.m. this morning, and Mr. Giuseppe Calabrese, our Italian speaker, dialing in from Australia at almost 11 p.m. today. He's the director at Space Architecture Think Orbital, and I have the honor and privilege this episode will be moderated by Mr. Mardis Bakley. He is the creative director in industrial design and adjunct professor in California, right, Mardis? Mardis is an American industrial designer and creative director experienced in consumer electronics, neurotech, sustainability, lifestyle, soft goods, and packaging. He has designed for the likes of Nike, Facebook, Logitech, Dell, Intel, Corning, Symantec, and for mid-sized companies and startups too numerous to count. His direct efforts have garnered tens of millions of dollars in sales and venture capital funding. Mardis teaches sustainability and social impact at the California College of the Arts. Him and his wife are with us together today, and the floor is yours, Mardis. You may want to introduce your partner and wife as a first speaker. Thank you, everyone, for being with us today. You have the opportunity after the speakers present to ask questions in the Q&A in the second half of this episode. Turning to you, Mardis.
Thank you, Hein. It's a pleasure to be here. As I have a very intimate relationship with sustainability and social impact. So again, it is my pleasure, and is also my distinct honor to introduce our guests, Fanam Bagley and Giuseppe Calabrese. Fanam Bagley is a partner at Nonfiction, a San Francisco-based design firm that turns science fiction into reality for a better future. She is a French industrial designer and space architect who creates cutting-edge hardware in wearables, audio, neurotech, biohacking, healthcare, education, sports, transportation, and aerospace. She specializes in turning groundbreaking technologies into attainable, intuitive, and beautiful products that help humans become the best versions of themselves. I will also introduce Giuseppe as well, and then we will jump back to Fanam and she can take it from there. It's my distinct pleasure also to introduce Giuseppe Calabrese. Giuseppe is an Italian award-winning architect based in Australia. He's an A+ member of the Australian Institute of Architects, passionate for architecture in extreme environments. He's a guest speaker at several conferences on Earth construction and a contributor to publications worldwide on the subject. Giuseppe is a recent first place winner at Mars City Design 2020, Urban Farming for Extreme Environment, and second place winner for the Ghana Arts Village using Earth Architecture and Extreme Environment Methodologies. He is a published author for contributions on Earth Architecture, Heritage and Restoration, Surface Structure Habitats for Mars, and he has a degree in as a violinist and is an active violin teacher. So thank you for both of you for joining us today. We're excited to have you. And I've heard some of these degrees and accolades for some time now, and it never ceases to surprise me what you both have done in your lives and the diversity of your knowledge. So thank you for bringing that to us today. And with that, I will hand it off to Funam Bagley and let her take it from here.
Hi, everyone. My name is Funam Bagley. It's pronounced like phenomenon for the ones who are confused. It's very, very easy. So super excited today to talk about sustainable living in space, I believe. And so I was asked to do like a 10-15-minute presentation on sustainable living in space. We can go like down 2 hours on that subject. There's so many things and exciting products out there to talk about, but this is the skinny of what I wanted to talk about today. So as the introduction said, I am a partner at Nonfiction. It started as a design company. Now we design everything from products to educational system, even countries. So that's pretty fun. But the subject today is about sustainability, right? And very connected to social impact. And our dedication to these subjects can be reflected in the way we connect with certain companies and organizations. So the UN put together the 17 Sustainable Development Goals. It has become a requirement to satisfy one of the 17 SDGs to work with us. Regardless of what industry you work in, at least you have to do something good for the planet, right? And then Material Connection is one of our partners. So it's actually a material library company. They also have material scientists. You can see behind me, this is not a fake background. This is actually our material library in our office in San Francisco. So we have access to all the latest and greatest and greenest materials that we can use in the project that we work on. And then finally, MIT Solve. The Massachusetts Institute of Technology has this kind of incubator for social impact focused project, and we get to give them a lot of advice as they're developing their solutions. So let's start by defining what sustainable means, because when you work in the world of architecture or design or engineering, it has become a little bit of an S word, right? People use sustainable in ways that they you can tell they don't really understand what it means. But to us, as of today, we would define it as a system that's abundant, resilient, or adaptable. It's a system where everything is interconnected. It's redundant, it's regenerative, which means that what comes out of death is new things that live, and it's circular, right? We'll go a little bit deeper into what that means. And one great example of a system that does all of those things is nature. And here we're talking about space, which, by definition, doesn't have much of living nature. It has other types of nature, but that puts it in a very interesting place to talk about, the edges of what sustainability means. So today I'm going to give a presentation that's divided in 2 sections. The first one is about sustainable infrastructures in space, so the stuff that is not us. And then the second section is going to be about sustainable humans in space, because you can't really think about infrastructures without the people who live in it, right? Especially since the space industry is welcoming more and more people with tourists today, and people going to the moon soon and heading to Mars in the next few decades. So let's start by, sustainability in terms of why it's important. The cost of sending weight to space has been very much, controlling what we sent up there, right? When back in 1981, it cost $85,000 to send 1 kilogram up to using the space shuttle. That's a lot. You can't really send anything you want or anybody you want, right? And then the cost has gone down a lot since then. And as of today, Falcon Heavy allows you to send 1 kilogram for less than $1,000. That's a drastic change. The goal for NASA in 2040 is to only spend tens of dollars per kilogram. And then once we have a space elevator, which I'm going to talk about a little bit later, it's just going to cost a few dollars per kilogram. And so that is going to help us bring more people and more things up in space. And where does sustainability, play a role in all of this? Well, let's talk about what's close to us first. This is a representation of space junk, obviously out of scale, but we have a lot of stuff that does not have any function up there. And it's very hard, difficult, and expensive to grab it back on Earth, back to Earth, and use it. So there's different types of startups and companies out there that are trying to capture space junk and maybe turn it into something even more valuable than what it is today. The problem with space junk is that, as you can see, it's everywhere. It's extremely dangerous for space travel, whether it's with humans or without. You have accidents once in a while that render satellites unusable because they have been in contact with space junk. So we need to really find a solution for this, because it's getting worse and worse, by the minute. This is a hopefully familiar craft that is floating up at 250 miles above the surface of our planet, called the International Space Station. It's a thing of beauty. It's been up there for about 20 years, and it's one of the you would call it one of the most sustainable systems out there, right? Typically, you have a crew of about 6 astronauts up there, living, working, and doing all those experiments in a microgravity environments. So you can see about half of the craft are solar panels. So the vast majority of the power being used there comes from there. But there's also, trips coming from Earth regularly, replenishing the oxygen, the water, propellants and food and things like that, to make sure that we still are able to make it function. When we go to the moon, when we go to Mars, we'll not be able to replenish things as often as we do with the ISS. So we need to transform what we know today about sustainability in space to the next level. So here's the ECLIS system aboard the ISS. So ECLIS is a acronym. So you see a lot of acronyms in the space industry. It's a lot infuriating, but it's an environmental control and life support system aboard the ISS. It's basically what is expelled from systems or humans and recycled into other systems. So you can see in blue on the left, for example, humans, have to urinate once in a while, and then part of that urine is recovered, turned into potable water, processed, and then used by the crew. So you can see all the different systems working together. And we recycle as much as we can. Obviously, there's some loss along the way because of inefficiency of the systems or just nature of molecules. But based on how this is designed, the way we live up there, the way we recycle and reuse a lot of things is a lot more sustainable than the way we live here on Earth. And we can learn a lot from the way people live in space. The circular economy is something I mentioned earlier. To recap everybody about what that means is, the source material is transformed into a product, is sold, is used, and eventually ends up in a landfill or is incinerated. There are certain things you can do to avoid filling up those landfills. You've seen pictures of landfills in different countries, taking over communities and making people sick. This is a huge problem, right? We're not going to be able to export our trash to other countries forever. So there are certain things we can do. We can start a culture of repairing the things that don't function anymore. We can reuse products in their original function or in different in other ways. We can refurbish products or have the companies that manufacture refurbish the products for us, or we can recycle. And as you can see, recycle has always been the poster child of sustainability, but honestly, it's a lot less efficient than repairing, reusing, refurbishing. So you've probably heard of, Elon Musk's dream of putting 1 million people on Mars eventually. The date changes all the time. But that's going to take a lot of technology development, of infrastructure putting in place, of like tests and failures, and putting humans in situations that might be a lot of firsts, basically. And so the difference between what's happening on the ISS, for example, you have a controlled environment that's very close to Earth versus a city with 1 million people, a lot of human error attached to it, and being very far away from what we know is going to be a huge challenge. So developing a lot of sustainable solutions is going to be primordial for us to even think that this is possible. So the problem with building a city, and you probably experience that when you travel, is that every single company, country, region has their own way of doing things. And you cannot be on Mars and be in need of oxygen, and you have your plug, which comes from the United States, and then it tries to go into the wall, and the connector there is from China, let's say, and then they don't match, right? We have to kind of work with the balance between competition and collaboration. In order to go to space, we need collaboration between all the agencies, between companies, private sectors, all of that, in order to go the right direction. We also need competition, because as we've seen over the last 15 years, competition is great for developing technology and solutions much faster and much more creatively, right? For a long time, we depended a lot on the NASA and the Roscosmos of the world to come up with all the ideas. But now, people from quote unquote smaller countries that don't necessarily have a space agency can be part of the space revolution. When we talk about sustainability, we have to talk about energy. So there's some really cool ideas that are being developed right now. For example, the US Air Force and many other companies are developing ways of harvesting solar energy above the Earth's atmosphere. So the solar panels that you see, at your neighbor's house, for example, are not the most efficient. Because the Earth's atmosphere is so thick, the rays coming from the light coming from the sun is being filtered, and you might not get the efficiency you need coming from your solar panels. But if you do that above the Earth's atmosphere, then you get all of it, especially if you have a whole area of solar panels on orbit. And then they're also working on how to transfer that energy from orbit down to Earth. And they're talking about microwaves, they're talking about radio frequencies, and to bring it down to Earth. So what's very important about this is not only bringing more energy to planet Earth, is also bringing it to remote places all over the planet. So imagine places in remote Africa or South America or Siberia, needing electricity, can have access to it for a fraction of what they have access to today. And think about the impact of this is going to help with access to energy, to power, access to the internet, access to education, which we've seen over the last year and a half is so incredibly important when you're stuck inside. Access to healthcare, and that can perhaps pull humans to a post-scarcity, era, because that's hopefully where we all want to go. Another really cool thing about technology. So MIT and other universities are developing ways to create artificial leaves. So this is a wonderful example of biomimetics or biomimicry. So you take a leaf, basically is an organism that takes light from the sun and transforming into something that's useful for us, let's say hydrogen and oxygen. And so if we can do this artificially, we can actually have in space ways to harvest the sunlight and turn it into something that we can use. So we don't have to like transport it or import it from other places in the universe. So that artificial photosynthesis is going to be like so incredibly important for the future of humans in space. Here you have a microalgae biofuel farm. So microalgae is like this magical organism. Is really small. It comes in like green color or red color or different color. They have like different purposes, but it can be used as biofuel. It can be used as food. It's extremely nutritious. It grows fairly easily. There's a lot of tests being done right now on how it grows in microgravity or partial gravity, which is always something tricky, but which is one of the reasons why a lot of experiments are happening aboard the ISS as of today. More than 6,000 experiments have happened in the last 20 years of the ISS, and some of it, actually a lot of it, has to do with what is the difference between what happens on Earth gravity versus microgravity, and microalgae is definitely part of the job there. So you've probably heard of the concept of a space elevator. It's basically being able to send things from the surface of Earth all the way to, let's say, orbit, not using propulsion, not a rocket. You would use a basically, let's call it a very long string on which you have the elevator going up and down and taking crew or taking equipment. So the space elevator doesn't exist yet because the materials we have access to that are strong enough to make that structure possible are either inexistent or extremely expensive. One of the huge contender for this is carbon nanotubes. It's a structure of carbon atoms that is so incredibly strong that people think it's possible. The problem with carbon nanotube is that it's insanely expensive, right? Like doing it in space elevator would cost like more money than any country would have. But there has been some really cool developments in the last few years using hemp. So some university is developing hemp-based carbon nanotubes that cost a fraction of what other types of carbon nanotubes out there, and perhaps could make the concept of a space elevator possible in the near future. You've probably seen, this very famous painting from Don Davis called the Stanford Torus. It's basically the idea of an O'Neill ring. So Gerard O'Neill was this man, like in the 1960s and 70s, thought about these giant architectures in free space, rotating and creating artificial gravity where entire cities or countries can live in, right? If you've seen the movie Elysium, that's kind of like how it's structured. So this is like super long-term view of where space architecture is doing and how we're thinking about putting humans out in space in mass. So that can be very interesting. As you can see, it's going to be impossible to do that without solving a lot of sustainable inefficiencies that we have today. Robotics are going to be extremely important. We're not going to send like masons on Mars to build structures for us or send every single habitats that we'll ever build ever. We'll have to use materials that are local because that's less weight to send, from planet Earth or for the moon or from anywhere else. And using these materials, using robotics to create structures on the surface of Mars can be very interesting. There's a lot of talk about using 3D printing, which is, basically using software to create and local materials, mixing them with materials we bring from Earth, perhaps, to create these structures that become habitats, that become greenhouses, and everything that is there to help us with exploration and eventually building cities. Another material that's really cool is mycelium. It's the bottom part of fungi. So fungi is this like mushrooms on top and mycelium's at the bottom, that white material that's made out of this very interesting fibrous network. So it's used in many different ways, like the big image here is biocycling, which is taking demolition materials and mixing it with mycelium. That makes a very strong material you can use as brick or insulation material. It's there's also universities out there that they're trying to control the way mycelium grows, so you can actually make architecture directly from how you code the growth of the mycelium, which is fascinating. So we talked a lot about structures and materials and energy, and it's fun. And now we're going to jump into the section where we talk about humans, because if we cannot send sustainable humans up there, then the architecture is kind of worthless, right? So let's jump into this. So in space, we eat. We have to eat, otherwise we die, right? In space, we sleep. But imagine sleeping in microgravity. When you're aboard the ISS, you experience 16 sunrises and sunsets a day. Imagine what that does to your circadian rhythm. It messes you up like so badly. In space, we have to work out because the human body is not used to microgravity, and it loses, bone mass and muscle mass, and a lot of physiological things go awry because we're not used to it. In space as well, we're thinking about sending people who are not necessarily what we call abled people, right? Like highly trained, ex-military doctors, multiple PhD type of people. In this case, he definitely has a PhD, but people with different bodies, people of different sizes, of different sex, of different types of cultures are going to go up there. And this is going to be forcing us, architects and designers, to innovate in these worlds. So one category that we work in a lot here at the company that I run is neurostimulation, neurotechnology. So it's basically reading from the brain or stimulating the brain in ways that actually support us. And so we designed this product that you can actually buy. It stimulates the motor cortex so you can learn movement faster. So imagine you're an astronaut and you have to work out and all that, and your body is just not used to working out, extensively every day, in microgravity. But you can actually create new neural pathways in your brain using this device in order to get there faster and get more efficiency out of your workout. So this kind of like non-invasive solution is going to be very useful for people in the future. And same thing with sleep, right? We designed this product for Philips many years ago where you wear it at night. And what happens is that it stimulates your brain during your deep sleep phase, so you can actually prune away extra information that you've accumulated the day before, so you wake up the next morning more refreshed. Because what's happening in space is that we live in a very dangerous environment. Like it's an extreme environment in every way. And if you are not alert, if you're not awake, if you're not aware of what's going on around you, you can be put in a very dangerous situation. So being sure that we get good quality sleep is so incredibly primordial. Robotics, right? Not everybody going to space is going to have like a specialist surgeon like traveling with them. So, if something goes wrong, you break something or you develop like cancer or whatever, you can have access to these amazing robots doing surgery on you or other types of medical, procedures. So multiple things can happen here. You can have like the devices be on the station or in orbit or on the surface of Mars doing the things to you, or you can have a surgeon on Earth doing the work using tools on Earth and having it operate on you on Mars. That's possible. You also have to like deal with like lag. There's like an 8-minute lag between Earth and Mars, and you can have to like think about this when you do surgery. But we are working to get a solution for this. you know, it's not only the physical aspect of the human body that you have to take care of, you also have to take care of your mental health. So this is a pod that is created by Sensing. It's a company that does multisensory experiences. So really digging deep into the world of synesthesia, which is the overlapping of sensory experiences in order to create something new. So this is, imagine VR, wind through your hair, aromatherapy, vibroacoustics, hardware variability, you know, light therapy, all those things working together to really bring your body, your mind, and your soul to the next level of consciousness. I think this is a way to escape, but to also give variety to the physical and emotional experiences of the body. And that is why, you know, when we live healthily on Earth, you know, we go to different places, we experience different types of environments, and we need to do that when we go to space as well, because that's very much part of who we are as humans. So one of the ways we did it here is that, you know, we're thinking about the interiors of these architectures in the future, massive architectures, and, you know, what kind of colors are going to have impact on our psychology, you know, bringing joy to us, bringing, calm or motivation or anything that needs to happen when we're working up there, giving us cues about how to import nature. We can't have like nature grow everywhere all the time. I mean, it would be great, but sometimes it's going to be difficult because of these extreme environments. So what happens when you create artificial nature that looks and feels and like nature itself? You know, when you touch it, when you see it, it lowers your blood pressure and it creates a sense of calm that will be very useful to you. And that's very useful in architecture that is going to be underground. So why would you create architectures underground? So the problem with a lot of the places in the solar system is that there's radiation everywhere, right? And when you have a very thin or no atmospheres on the surface of the moon or Mars, you get hit by really high levels of radiation. You also get hit by micrometeorites. That's typically our Earth atmosphere, kind of like eliminates a lot of that. But when you have no atmosphere, you're exposed to all of this. Another thing that's happening on the surface is, especially of the moon, is the drastic difference between the highest temperature and the lowest temperature. And that creates a lot of stress on the architecture that we would export there. So going underground would be very, very useful. And the moon happens to have, lava tubes. They are natural structures. They're between like 150, 300 meters in diameters, and they're protected by about 40, 50 meters of basalt, which is this like very dense rock. And so creating structures underground are going to be great, but that doesn't give you access to light. So using artificial light, LED lights and colors and things like this to create rhythm, the circadian rhythm again, and to make sure that everything in our human bodies are regulated the right way is going to be so incredibly important here. And so, thinking about interiors as well, we have to stop thinking in military ways, right? Aboard the ISS, you don't cook your food in a kitchen, you do that in a galley. You don't go to the bathroom or, you go to the laboratory. You don't sleep in your bedroom, you go to, sleeping quarters. So changing that language and changing the way we think about designing this space is going to help us, non-professional astronauts, want to go more in the future. So here's an example of, what a bathroom spa, looks like, all of these details of warmth and attention to details and almost luxury are, could be good ideas to implement there. So last year, I was involved in a project with the World Design Organization and the ISS National Laboratory, which is like the science branch of the ISS. And what we had to design was an orbital university. And so this is a structure on orbit, probably low Earth orbit, that is going to link universities and school on Earth and this kind of like a giant lab on orbit. And what that does is it gives access to people like you and me, to microgravity environments. And that's going to be very useful when we try to develop the space industry beyond science and technology and engineering, right? Because a lot of the time when you ask people, what do you want to do in the space industry? For the vast majority, people think of science, technology, and engineering. But the arts, the social science, and all of the things that make us human need to be exported into space and tested and experienced for us to be even able to think about a future of a city on Mars. And so creating, in each of these pods, you have like labs and people can go there and work for, let's say a few months and try to like find solution for, let's say, growing food and hydroponics and all of that, or even like having like artist studios where they can create art in microgravity. That can be super interesting. In microgravity, you can also, develop the future of food. So this is actually a project that we did for NASA and the Canadian Space Agency. They they put on a competition that just closed recently, and how to create nutritious, beautiful, and appetizing food up in space so we can go to Mars, right? So the food that they eat right now is mainly freeze-dried food or fresh food that is like freshly brought from Earth. But when you go to Mars, that's like 6 to 9 months there, a year and a half on site, and then 6 to 9 months back. That's a long time. So you have to have like systems that are completely independent and are sustainable enough to be functional. So creating appetizing food, things we like on Earth, like a chocolate sauce and food made from shelf-stable products that actually taste good in the mouth is so incredibly important. So when you fly, I don't know if you know that, but when you fly, your taste buds change, and you actually require a lot more extra flavor, more salt, more sugar in order for you to even feel the food that you're eating. So it's the same thing in space. You need to really make sure that the flavor profiles are really good. Another thing that's really fun, and there's certain things that we've been doing for millennia on Earth, like grilling food and making it appetizing this way. But you can't have open fire in space. That sounds super dangerous. But we can use other technologies like laser. So we started lasering a bunch of like chicken pieces here at the office. It was really fun, and we tasted it. And it tastes really good, right? It's a huge difference when you think about the future of food and how appetizing good, nutritious food can be. Another thing that's on people's mind in terms of nutritious food is using bugs. So there's this amazing chef based in Brooklyn named Joseph Yoon, who's a real chef who's cooking like very appetizing food. I mean, you want to put this in your mouth, right? Well, there are some, insects in that food. What's great with insects is that they grow like super fast. They're very nutritious, and they're cheap, right? So or almost free. So using sources like this is one of the things that the space industry is thinking about, not only for the space industry, but also creating solution up there so we can bring them back to Earth and maybe solve the problem of hunger all over the world by providing protein that can be appetizing as well. So I talked earlier about arts. So this gentleman, Yusaku Maezawa, is a Japanese billionaire. You've probably heard of Dear Moon, which is this mission to the moon where he wants to go around the moon with 8 artists. Art is very much part of who we are as humans. When you look at excavations from like lost societies, what's left? There's pottery, there's architecture, and there's art, and all of the there's not much left. All the quarrels, all the murders, and the society conversation, all that is lost, but we still have art. So what kind of civilization do we want to leave behind from there? And when we talk about art, it's not only paintings, it's also other types of art, dancing, expressing ourselves as humans in microgravity can create new branches of art that we don't know about yet. So all of this is really to think about the next generation. I want, girls from Afghanistan, boys from Bangladesh, and people from, the Congo and all those countries to believe that they too have a chance to go to space in the future. And so this is, a very cute photo shoot done by Thomas Olivier, who's, of like boys and girls all over the world in spacesuits. Is pretty great. So why are we doing all of this? Sustainability, thinking back of what we can do to planet Earth. How do we take all of the bad habits that we have, built over specifically the last 150 years and almost re-terraform planet Earth? So one way of doing that is sending people to space, because what happens is what's called the overview effect. Here you have an astronaut looking back at planet Earth after being launched into the ISS. And what she's experiencing is a cognitive shifts where she sees planet Earth from space and realizes that it's a very small planet, it's very fragile, the atmosphere is very thin, and we have to take care of our planet. So the more people we send to space, the more they experience the overview effect, the more we can have these people influence all of the infrastructures that we put on this planet to, again, re-terraform planet Earth, because that's what we need to do in order to even think about being sustainable elsewhere in the solar system. And I want to end this presentation, sorry, a little bit too long, about with this famous picture of Earthrise. This is a picture taken by William Anders aboard the Apollo 8 while he was orbiting the moon in 1968. And this is the picture that launched the environmental movement, right? People didn't really think of the planet as something small, fragile, like the pale blue dot, as Carl Sagan said. And we have to remind ourselves that we go to space for Earth. We expand our humanity beyond the limits of where we're born for Earth. And we develop all of these technological advancements to benefit Earth and ourselves. So that's it for me today. Thank you for listening to me. And if you want to follow us, these are the links. Thank you.
Wow, that is fantastic, Phenom. Thank you, as always, for sharing so many different thought-provoking ideas, images, and really challenging us to look at sustainability as something well beyond just materials and processes and systems, but also the humanity of it. What does it mean to sustain culture, and what does it mean to sustain art, and even sort of that sustainable psychological state as we go from planet Earth out into the greater, solar system and hopefully beyond. Thank you so much. So with that, we will jump to Giuseppe. And Giuseppe, as a reminder, is an Italian award-winning space architect, currently based in Australia. So with that, Giuseppe, I hand you the torch.
All right. Yes, welcome everybody. My name is Giuseppe Calabrese. I'm based in Australia. I'm an architect. Welcome to this episode, SpaceConneX 59. So in doing this talk, what we're talking about sustainable living in space as the future of food, materials, energy, and consumption. What I've found that it is interesting, as all these different subjects are quite intertwined with each other. It's also hard distinguishing one section from another, and I'll go through this during the talk. So what's happening all over the world is these greenhouses, which are space analog test facilities. This one in particular in the image is called the Eden ISS. And it's like a shipping container. So what they do in here is a lot of experiments. And so they work on the delivery of nutrients to the plants. And they also analyze, for example, the spectrum of lights that's delivered via the LEDs to these plants. And of course, all of these analogs are very important for the ISS. They get done in an extreme environment. So this one here is in Antarctic. And on the ISS, for example, they do similar studies. So, how does the microgravity affect the movement of the nutrients through the roots? So we have to do a lot of experiments, and it's very important that we have these. So the original team for the ISS then basically conceptually adapted their base in Antarctica for a space. And from what we see here, sort of a space, a shipping container, they created it into like a cone, a hard cone, a cylinder, which I'll show you shortly. So talking about keep on talking about the future of food. What we have is, let me just reduce this. Ideally, what we want is a closed-loop system where greenhouses are not an accessory, they are necessary. Sometimes we see in some renders, we have a beautiful render of a space station, but then in terms of plants, there's just a little pot in an angle. So the way I think about it is the whole settlement has to be a living organism. It has to be able to ingest, digest, and excrete air, soil, and energy. So these greenhouses are fundamental for space and for living in space. So these ISS cylinders, they could work together with a system that's been introduced by Michael Smith. Michael Smith is a physician, he's more than 30 years experience, and he's developed this green powerhouse. And the green powerhouse, there's a lot of literature and scientific papers that come out lately on it. It's basically made up of three parts. They're anaerobic bioreactors, the photobioreactors, and these carbon engines. And what they do, they all work together and they create, from waste, they create soil amendments and energy, which is a fantastic thing. And he has created this on planet Earth already. One important material that comes out of this whole process is called biochar. And this is a charcoal, which is essential. It's where the bacteria will live, and it's created in absence of oxygen. You see, what's happening on Earth is agriculture is the most damaging element that we have a process on our planet because it's depleting our soil. It's envisaged that we have only 60 years left of workable land until it gets completely depleted. What's happening? We have more and more people, of course. So agriculture, we have to produce a lot of food. So we put in a lot of fertilizers. Then we have a lot of super bugs, super weeds, and the soil gets depleted. So this system here is a step forward. Basically, it creates soil from decades in a matter of days. So it's a very, very interesting system that that has to be taken in consideration moving forward. And of course, with all this, then there's a SCADA system. So we're talking about all the mechanical ducts, sensor valves, and pumps that work together with this system. Okay, so in terms of the future of the food, we can distinguish here what's happening in the ISS and the way things are moving towards this green powerhouse. So on the ISS, what we have are air scrubbers, dehumidifiers, separating toilets, and all of this waste gets incinerated. Now, when it gets incinerated, obviously there's going to be some sort of problem down the track somewhere, and they utilize these mechanical systems, which let's call them more reliable. So what has to be analyzed is more a green powerhouse where we have a closed loop ambition. On the ISS, I believe they're around the 91, 92% of closed loop and recycling. But what we want to do is try to bring that to at least 98%. So we have algae and bacteria, and they produce food, water, and O2. And all of this human waste, instead of getting incinerated, gets put into a big digester tank and recycled in the system. So obviously, the bigger the system, and the more efficient it will be. So we can start with little plants, and then we can have big trees. So we can start with little fish, little prawns, and then we can have bigger plants, and we can have bigger animals. So this whole system needs to be integrated in the design. The way I see it, we shouldn't be having this little pot in a corner. When we talk about sustainable design, we have to expand the definition of sustainable design and have this part of a big system where the greenhouse is an essential part. Because in space, of course, we need to eat. We can't always be importing, it's called the up mass, bringing food up and bringing the waste down. Eventually, we need to create food. And so all of this, of course, is still in its infancy. There's still a lot of studies that are being made, but it's something to seriously consider. Okay, just going to bring you briefly through this design that I did that was for Mars City Design. It was for 2020. If you want to see the animation, you can go on YouTube and just type in Sprout and my name. But I won't show you that here. So what you can see in the top left image is basically what I was talking initially, these the ISS cylinders. I have adopted them in here. And now this links to the future of the materials in construction as well, because if we bring food and we want to have these cylinders, we cannot just have them lying on the ground, because we have massive cosmic radiation. We have changes of temperature that are very extreme. We're going to have meteorites. We have we don't have atmosphere. So the situation is very different from Earth. So what we need to do is create a shell that will protect these structures. So these shells will be done initially by robotics and telerobotics. And then these cylinders will be sent by Earth, pre-implanted with seeds. They'll expand and be hosted inside these shells. So future buildings will also be energy producing. So they'll produce their own energy. There's a lot of scientific papers also with, for example, they're creating slabs at the moment, concrete slabs that are batteries. So we'll have a positive and a negative side, and all the energy is getting stored inside the slab. So there's a lot of progress in this moving forward, which is very interesting. So getting into a little bit more detail here, the way I see it, so there will, in this competition in particular, there was at the center of this design was the green powerhouse. So the green powerhouse is like a big machine. It's like a big star, and it has these branches that come out. And so we have pressurized compartments and non-pressurized compartments. So in these pressurized compartments, these will be the ISS cylinders where we have all the plants, and specific ones will be also for the habitations, obviously. And the center will be a green powerhouse where we put all the waste, this photosynthetic core, and then we get the bioproducts. So this, what we were talking about, the biochar that gets then resent back into the pods. And as we grow, we expand, we have more waste. This will fuel the green powerhouse, and we can expand as a colony. So we're creating food and we're reusing our waste. So the waste is actually necessary. And that's a fantastic system. And it's a fantastic problem to have, because it's no longer a problem like on planet Earth. What we have here is, this is just an image, a render of the outpost. And what I did, I'll just zoom in here. You can see I studied the mineralogy of the Jezero crater, because this is where the rover recently landed. So I studied this mineralogy, and what you can see from the picture in blue is the smectite. So I always like basing myself a lot on science rather than coming with pseudoscience, which I'm also interested in, or science fiction. So here what we have is smectite. Now, having studied the Earth buildings, I know that a smectite is used on Earth for the last render of a lot of Earth buildings. And I analyzed a lot of Earth buildings in Italy and had this smectite on the it's like a sacrificial layer. So every time it rains, the smectite will crack and it will expand, but it will protect the wall that's underneath it. And it's not very good material to use on Earth, because the smectite, when you create Earth bricks, it will actually expand and contract, it will crack. But it's fantastic on Mars because we have it, and there is no rain there, and there is no humidity. So it works out to be a fantastic resource to have. So linking again to the construction, also interesting will be 3D printing. 3D printing of certain types of vaults. So the vaults, in this picture that you can see, we have Nubian vaults. Nubian vault is a vault. Imagine this can be created in bricks on Earth. And you don't need any scaffolding, you don't need any support underneath this. You just start at a 0 point, and then you start printing, 3D printing this, and you create suddenly a roof. So that's very fascinating. And what I did, I reinterpreted, I studied heritage basically as a master. And with the Nubian vaults, it's a fantastic Iranian system. And you link back to the past, like Nader Khalili or Hassan Fathi. So the big architects of the past, and reinterpreting that history that we have for a new planet. So how did we start building on Earth? Like what materials did we use? So these are very important concepts to look at the past, to have ideas for the future. And with the bricks, so of course with the smectite, you can create these bricks. And my idea was, of course, that one to create these big blocks in a Lego fashion that then click on top of each other. Of course, this is just a little percentage. It's an idea. It's not meant to be, okay, this is the solution. I suppose everybody has a different vision, and all together as a collective we work, having a step forward for humanity. So linking back to food, because the competition was for making 9 astronauts survive for a period of 2 years on Mars. So how are we going to do that? So there was this software called CMOC, and this CMOC is in collaboration with National Geographic. Basically what it does, it has all these different types of vegetations. And I had to select certain types of vegetation. So what I figured is that, for example, if I was selecting grain, it will take 4 or 5 months to be able to bake a cake from that flour. It will just take forever. So an important thing to do was to think, okay, so for example, I want to have pasta. So how am I going to make this pasta if I can't have grains, for example? So grains, that will take a lot of resource. And this CMOC software would show you how much oxygen you had, how much CO2, how much water, how much waste, how much of everything, how much fuel you have less than power. So it's really interesting. So what I went for, and it was successful, was this breakdown of peanuts, rice, lettuce, tomato, spinach, radish, snap bean, pea. And then of course, you had the habitation. When this then gets scaled up in the bottom right image here, you can see this sort of snowflake, this fractal shape where I also include, as Fernand was indicating, the insects. They're very important because the insects, they are the future. So we're going to use them for protein, but also we need them to pollinate the plants because we need the seeds. So this whole system needs to be closed, and the seeds are very important. So when we go to space, I think, yes, we are doing it to explore a new planet, to gain advantages in knowledge and in science. But the most important thing for me is that we create a super seed. So a super type of plant that is really resistant to gravity, is really resistant to an extreme environment. And that seed, then we bring it back to Earth. And then suddenly we've got a super plant. And I think we have to think of not exploiting the other planet, but actually learning from it and creating these new plants that we can bring back to planet Earth. And that will be much more resistant to our planet, which is, as we know, there's global warming, and our agriculture is very destructive in the process. So we want to protect our own planet by using these super seeds. Here we have just an outlay of the whole system. So you can see, let's just call these snowflakes, and we have every snowflake has its own green powerhouse, so independent from each other if something was to happen, and then communication roads. So we have to think about how is this going to expand in the future? What type of architecture are we going to do? Are we going to do what we're doing here on our planet? Art Deco, futuristic, or like a lot of different styles? We don't know what's going to happen, but it will be good to have a planning layout of what we're going to do and having roads that don't intersect each other. So they start from one point and you can travel from one place to another. And so on the top right-hand corner, you can see the Jezero crater and the blue area of smectite. And then, of course, we need a massive solar farm, energy generators, and we can take in consideration, also the layout of the landscape. So we have these other little areas where we can put our energy sources like nuclear generators. So these craters can be taken advantage of. Okay, so we just go rapidly through the interiors. So this is the green powerhouse section, and the solar collectors, of course, will be very important, and they'll be collecting sunlight and giving light back to the interiors of these ISS cylinders. Here we have the Nubian vault will be printed with basalt and bioplastic. And one important change that I did to this ISS cylinder was to have skylights on there, so that with the silica printed skylight at the end of each of these Nubian bulbs, we could take advantage of some of that sunlight, which will supplement also the LEDs. So we have to think about new systems, because of course the supplies are limited, and we must be as sustainable as possible, trying to reduce our need for the LED lighting. So on the top right-hand corner, so you can see a rendering of the rover. The way I envisage it is that, yes, we'll have lots of rovers, and these rovers, I would like them to have as many functions as possible, so that if one of them fails, we don't have to rely on a resupply. So they would have mechanical arms. They will be able to 3D print as the bottom image. So they will be able to compress, microwave the blocks, compressed, the so-called CEB on Earth, but on Mars, I suppose it'll be CEM, compressed, so CMB, it's compressed Mars block, but we haven't done in that into detail. So there will be elements that will be lifting, like scissor hoists. So these rovers will be very intelligent. They will be maneuvered from, it could be orbit or a space station, and they will be building all of this complex first. And then the pods will be arriving, the cylinders will be arriving later. They will be sprouting, and then the astronauts will be arriving and consuming the produce. So I suppose what we have in this bottom right image is we have half Mars and half Earth. So what we want to do is we want to have this system on Mars, yes, but we want to have it also on Earth, where we take advantage of these seeds, and we can bring back technology and fight against global warming and have a sustainable system. Okay, so linking back to the future of food, yes, there's a competition that recently concluded with NASA, which I wanted to participate in, but I couldn't. Only Americans can participate in that one. And the future of food, there will be, of course, 3D printing. There'll be astronauts like Chris Hadfield. He had an interesting comment that he was saying that without gravity, the astronaut sinuses, they get clogged up and they can't really taste anything, much of anything. So I think a very important part of this will be a tactile. So being able to touch the food and look at it, but also the smell will have to be very intense. And there'll be machinery that will be able to print menus. And preparing food can be interesting for some, but it can be also a chore for others that would not be interested, and they just want to eat and get on with their day and their exploration and their missions and what they're really there for. Okay, so the future of materials is linking back to the past, and here we have Nader Khalili. Nader Khalili, he was an architect, and he participated in this competition for the moon, where he introduced this system. Well, why don't we get the lunar dust and fill these bags and create these cocoon-shaped buildings? So very interesting. If you want to know more about these type of buildings, you can look at Cal Earth in California. And these buildings are very resistant to earthquakes because they've got this cocoon shape. You can think about Gaudi and the catenary structures. They're very impressive. The bottom right-hand corner, we've got an inflatable structure, and then we have these, because the inflatable inside will have a big pressure, it will be able to then, the weight is different because we're on a different planet, so we have a different type of gravity, and we'll be able to easily be covered with these sacks of lunar dust. And of course, we'll have 3D printing. 3D printing is the way forward, and there's a lot of studies that are being done on the planet Earth. These studies need to be kept going because, you see, they have to be done in a certain environment. What happens on Earth doesn't exactly happen on other planets. For example, when we print on another planet, maybe the spout will be clogging. Maybe these layers, they'll laminate because we have huge temperatures, and then we have far under zero temperatures. So maybe all these layers will be separating. So there's a lot of technology, a lot of studies of new materials are coming out as to how to best 3D print and how to best go about all of this 3D printing. So necessary constructions elements will be, of course, communication, so roads, landing pads, access, shielding. So we need to shield anything that we have from radiation. We'll have meteorites, exhaust plume protection. So think about when the rocket comes down on the planet, the amount of dust that will be moving everywhere. And the dust goes absolutely everywhere, and it's a very sharp dust that can destroy machinery, so it has to be thought about. Then we need blast protection for anything. So for hangars, equipment, lighting, power, the plants and the inhabitants, trenches for the infrastructure, burial and the foundations. And then we'll be mining equipment for regolith, for construction and mining of water from the craters in shadow. So thinking about going to another planet, there is a whole range of things that we need to think about. It's not only the actual habitats. Just want to share here what I'm working on currently. This is super exciting with this company called Think Orbital, and what we're working together is this orbital space station. It's denominated the Orbit 2, and it's basically a concept for a low Earth orbit station, and with the goal of maximizing the habitable volume. At the moment, we're working on a 2,000 cubic meter, and we're also working on a 4,000 cubic meter, so two different styles. What's very innovative about it is that it's an empty habitable volume in space that's done with one single launch and utilizing on-orbit assembly and no EVA, so extravehicular activity. So the space station has got these pods that are like these service modules, like you can see at the bottom of this rendering, they get attached to each other. While this one here, I'll show you in the next image, gets flat packed like a little box, and then you have this robotic arm in white, like a Canadarm, and basically mounts this whole thing like a big flower. So it's very interesting. And with the explosion of space tourism, and the ISS is getting dismantled, and the next 8 to 10 years, there will be no International Space Station. So what NASA is trying to do is emphasize the need for, future space stations. So, and there's attractive opportunities, of course, for the space industry, for space tourism, research, manufacturing, and this lunar economy is just growing very rapidly. So it's very, very exciting at the moment working. So what we're doing here, you can see tessellation. So basically, it's a fancy word here. So it's we're fitting geometry in this very tight-knit space. So you can see the fairing separation here, that first image, where all of this is flat packed, and then suddenly you get the Canadarm similar robotic, and it starts mounting this flower. So we've got hexagons and pentagons, and then they get closed from inside. So basically, from a flat pack element, we've got this massive sphere, which is 2 times the International Space Station, and we're fitting it out with different users. So at the moment, we've both participated in an actual space station, and we're also fitting it out as a space hotel. So, and of course, it can be fitted out for many, many users, and we are very exciting and working on this. Okay, so here, the goal for NASA is to avoid a gap between the end of the life of the International Space Station and the beginning of a new one. So NASA is acquiring services from a viable commercial destination, and we hope it will be Think Orbitals. And just 2 days ago, we've been working night and day on this. We participated in a Space Act agreement to support the formulation design of a road to commercial LEO destination. So we hope we're going to get selected after all the work that we put in. And we've got this spherical shape, and has a huge amount of advantages, because it minimizes the surface to volume ratio, and minimizing the area that needs to be shielded. If you think about, for example, meteorite hitting this, we're hitting a very, very small surface compared to if we had, for example, a very flat surface. So, and also the stress is caused by the internal pressure distributed uniformly inside when you have a spherical shape. And we're going to use electro beam welding for all these parts together. So yes, we are hoping that this will eventually take place. And I think that's about it from me. Thanks so much for your patience, and I think we will stop here then.
Wow, that was amazing. Thank you, Giuseppe. Really exciting to see all the work you've done, an amazingly well thought out process. And this is the kind of thing we do need when we start venturing well beyond our planet and into these extreme environments. So thank you so much. I have a few questions for you all, and then I know we're taking a few from the audience as well. So maybe we'll give about 10 minutes for that and see where it takes us. So first question is, well, we've talked a lot about like circular economy and how we have to have a closed loop system, recycling, if you will. And one of the first slides Phenom put up was, things are getting cheaper to put into space, which is great, which allows us to explore more and discover more. But at the same time, will the low cost of putting things into space make us as humans be more careless about what we put into space? And what I would, to elaborate on that, is this our equivalent of single-use plastics in space? How will we address these issues? And can we transfer these new habits back to planet Earth if we can solve them, in fact?
I can start. Thanks, Giuseppe, for your presentation. That was awesome. So yes, humans, you can always rely on them for making the wrong decisions when it comes to habits, whether it's, what they consume or how they throw things away. I think the reason why we've been treating this planet this way is because of many things. One, there's a complete disconnection between, let's say, an end product and what it takes to fabricate that product, right? Very few people are aware of, mining certain resources and transforming them and having like toxic chemicals being put into place and a lot of waste along the way, travel and shipping and, the consumption of energy. So education is number one. We have to educate people who go up there that of where things go and why they shouldn't have certain habits. And I believe that, that's what they do with astronauts. We're not sending millions of astronauts as of today, so we can control that. Another thing that we need to think about is the balance between business and responsibility, right? So the way the world works today, everything is driven by money. Like that's really it. And we need to think of like systems put in place by thinkers today called natural capitalism, for example, which is the balance between the economic, the social, and the environmental. So every time you make a decision yourself, or the infrastructure that makes decisions for you needs to think about the balance of all of this. That's how I would answer that question. Thank you.
Yeah, definitely. Giuseppe, any thoughts on that? And if not, I also have a question related to that for you specifically.
Yeah, I'll touch on base on that. I think they're estimated to be around 130 million pieces of debris smaller than 1 centimeter. I know this was from 2019 that are in the space, approximately 900,000 pieces that go from 1 to 10 centimeter. And so are we going to be more careless? I hope we are not going to be. These spacefaring nations have been filling Earth's with satellite, GPS, all these weather forecasting and telecommunication. And this space junk, unfortunately, is just going to grow. And more satellites are scheduled to be launched. I know there's also the orbital mitigation standards in the US, but for these funding of the cleanup operations, and these cleanup operations are going to be something that's going to introduce a lot of business. A lot of companies are coming up. They're going to be the cleaners of space now. And for example, even when the Chinese launched their rocket, that was, and they've been, I know, bringing down another rocket, and they destroyed it, and they created so many fragments these fragments will be around for a long time. So we have to avoid all of these little pieces then colliding with the space station. So I hope that yes, there will be a good balance between the private interests, because yes, when there's private interests and capitalism and business, unfortunately, I think there will be a lot of launches, and we have to be careful about it.
Absolutely, it's definitely getting crowded up there, and being conscious of that takes a lot of computing power and a little bit of luck, I think. But Giuseppe, you had mentioned the digestive system. So we have this sort of circular economy or circular system in space where you're taking human waste, water waste, things like that, recycling it and using it for various different things, cleaning the water or using it for soil. Is there anything that can be done or is already being done for, say, the single-use plastic waste? So right now we're serving, freeze-dried foods in plastic containers. What are the astronauts currently doing with that? And is there a better option?
Yeah, so I think, yes, we need to go probably into bioplastic or plastic that is derived from plants. Yes, because as I was mentioning during the slides, is that we have a massive amount of material that even with this work that we're doing with Think Orbital, we had to introduce the amount of upper mass and down mass. So the down mass can be every 6 months around from the ISS around 2,000 kilos, and it's a huge amount of down mass, and a lot of this gets incinerated, and it can't be just continuing this way. We have to imagine if there will be all these orbital stations around our planet. Are we all going to supply them food and bring down little plastic or aluminium compressed vacuumed junk back to Earth, and what are we going to do with it? So I think we really need to start thinking more and advance science in this in this area. So yes, definitely cardboards and bioplastics and materials that come from plants. And as Flam was indicating, there's so many different plants that we have to start exploring their properties for just the materials that we can derive from them that we may not even know at this stage.
Great. I love this idea of dual use. The military does it a lot. We develop technologies for military, and then they can be brought to civilian life. And we also do that in space. Things are developed in space that can then be brought back to, planet Earth. Wouldn't that be great if we kind of recalibrate what it means to be sustainable, recalibrate what it means to have trash, and then bring that knowledge and those experiences and technologies back to the Earth to inspire us to be a little bit better about our environment.
Absolutely.
So another question, Phanam, I loved your leaf example, inspiring artificial photosynthesis. And similarly, Giuseppe mentioned the Sprout Mars architecture. And it reminded me some of the structures on planet Earth, and almost fractal-like or snowflake-like. In my practice in sustainability and social impact, we often talk about biomimicry. We know there's no living biology in space that we found as of yet, fingers crossed type of thing. But are there things that inspire us on other planets or out there that can help us build in sync with those existing ecosystems or existing systems in outer space? Some of the things I think about are like, is it, weather or, regolith, things like that we can take inspiration from to further advance our efforts there.
I think being in these extreme environments kind of forces you to come up with innovation anyway. For example, being in microgravity, you have to change a lot of things, right? Opening a door on planet Earth, you put your hand on the thing, you turn and it opens. Opening a door in space, you kind of have to hold on to something and then find your way to open it. So everything changes. When you're on the surface of Mars, as you saw, with the Ingenuity helicopter, it's not like a helicopter that is designed for the Earth's atmosphere, because the density of the air on Mars is so low. You have to like rotate that thing much faster for the thing to even like take off. So I mean, there's so many examples of like the innovation that we are pushed to do in order to make very basic things function in other worlds. And all of these innovations are going to be brought back to Earth and perhaps, you know, be used in these specific applications, or can be applied to other industries, so you can advance, you know, everybody's advancement.
Great. You know, I've heard recently that, you know, we make PV panels, photovoltaic panels here on planet Earth out of a certain, you know, silicone base. In outer space, it's a slightly different structure, because you're picking up many more wavelengths, because the filtration of the atmosphere is slightly different. And I kind of love this idea that, like, you know, we actually are kind of forced almost to learn things new and then maybe reapply them to life back here on planet Earth.
Yeah, and we're thinking a lot about what we need now. Usually we create things as we need them, but you have to think that the future of humans, you know, in space is going to include at some point like human reproduction. You know, you'll have to like send families, they're going to be like never see Earth again, and they'll want to have babies, otherwise they'll just die off. So having babies in microgravity or partial gravity, or under the levels of stress that are more common in extreme environments, how does that work, right? There are talks about ectogenesis, for example, which is growing embryos and fetuses outside of the human body. And so many things having to do with, you know, when you talk about radiation protection. You know, will the radiation change us? You know, it changes the DNA a little bit. You know, what is that going to do generation after generation? Are we going to be people who perhaps will not be able to live on Earth anymore because we have evolved into a subspecies of humans that actually works in different environments?
Yeah, that's really the ultimate of sustainability, right? If we evolve as humans, what's sustainable for us now? You know, how do we change? What needs are we going to have in the future? It's really exciting. I have one more thought, and then I'll hand it off to the audience, or Hen to ask questions. And this is more of a thought than a question, but I want to throw it out there. When I'm thinking about how we interact on the planet Earth, you know, over millennia, humans have been occupied by meeting their most basic needs. So we're talking about food, shelter, safety, things like that. And think about it as Maslow's hierarchy of needs. Now in space, it's interesting because we're kind of forced to have those basic levels met. We have to have air, oxygen, we have to have heat, we have to have food, or we just can't survive. So if we look at that, and similar to history on planet Earth, once all those basic needs are met, we have a lot more freedom to think and do things outside of those, you know, sustaining operations. We can philosophize about life. We can think well beyond just the day-to-day. And I wonder how, you know, if we can satisfy those most basic needs in space, people, will they be more enlightened by living in space? Will they have an opportunity to grow cognitively and look well beyond the current human condition on planet Earth? And I think when we talk about, like, why do we need to go to space, this is a really interesting question about maybe this is part of our evolution into a higher being or a higher consciousness. So feel free to jump in on that if you like.
I have a thought. So what you're describing is essentially a post-scarcity society where you don't have to like meet the basic needs, right? So think of about the history of humans on this planet. This planet is designed to be flourishing with everything that we need. And yet we have found a way to create scarcity, to create hunger, to create wars, to create all those things. So I'm not entirely sure that doing this in an environment that can kill you is going to change. So perhaps there's something about human nature that we have to understand and reconsider in order for us to believe that a post-scarcity society is even possible.
Yeah, I know that the astronauts, they describe a sort of a cognitive shift in awareness after they see our planet from a distance, and it's sort of like they describe it like a ball hanging in the void. And they have the sense of understanding the big picture and feeling connected, and that sort of the realization that we are all traveling together on the planet, and we should look at the world from that perspective and seeing that nothing is impossible. And hopefully on the next planet we have more collaboration and less division. And I mean, our planet is beautiful, and it's just a pity that we have separation and division and wars and so many problems. And yes, you want to hope that in the next tentative that we have, that this is thought through, and we come together, and because we want to grow. So Earth is our cradle, but it's just our cradle. So I don't believe that we have to be here forever. Eventually, it might take 100 years, but we're going to be on several other planets and have backups on, and there will be different types of humans and different types of planets that will be eventually, because the gravity is different. And I think, when you'll be on Mars, people will think, wow, on Earth there are trees, there are birds, so we have such a lovely planet. And I think we will be envied from the rest of the other planets. So we'll be the other way around at one stage.
I love that. It brings sort of respect for our home planet back to like how we look at the entire solar system and beyond. With that, I would like to pass it to Haim to see if you have some questions for the audience.
Thank you, Martis. And there's a question from Mitchell in regards to insects. There's actually a couple of insect questions, Fanam. Silkworms produce cotton. How could cotton be used in space for sustainability? Can we realistically get to Mars by the year 3000? What are your thoughts on this?
Yes. So it's not cotton, it's actually silk. Cotton comes from a plant, but yes, it's thread that we can use to make, like thread and fabrics and different things like that. That can be very useful. Like everything that we want to grow in space, we need to make sure that they grow, right? Because humans, as we know, are affected by being in microgravity, or we make the assumption they're going to be affected by partial gravity as well in the long term. It's going to be the same for these insects. So how do they grow? Are they going to create the same type of silk, or is it a different type of silk, right? What is the function of silk in silkworms? Is it just to create a cocoon, or is it something else? And what does a cocoon even look like in microgravity, right? I don't know. So it'll be very interesting to see that, and also how we bioengineer these silkworms, right? Perhaps we make mega silkworms that creates 1,000 times more silk. I mean, that sounds a little crazy, but I'm sure someone's thinking about that. But always thinking about the balance of things, right? Yes, we experiment in small quantity first, but what does it mean in terms of like creating an economy around space silkworms? That sounds really cool. Right.
Thank you, Fanam. Yara asked, are there any other affordable, give me a second to read her question out here. Besides insects, what other kinds of ingredients can be used to make safe and quick meals at low cost? Would you like to take that, Joseph?
Oh dear. Other insects, yeah, I've thought about a lot about insects.
It's a French thing, right, Fanam? The insects.
Yeah, the insects are fantastic. Yeah, so as opposed to we have to wait for future progresses in science. we wouldn't want to use, artificial, bioengineered type of food. We want to have something natural that we can use, and I suppose extract. We need the extracts that we can bring in there, and from those extracts create meals. But apart from insects, I'm at a loss as to what else we could use at the moment.
Well, Giuseppe, I wonder if the exoskeletons could be used as some sort of building material or in construction somehow.
Yeah, that's definitely a possibility. I mean, there's so much exploration that's happening now. It's a great period to be alive, and every time you look at the new scientific papers, there's some sort of innovation. You thought, wow, I've never thought about that, and how's that possible? They're doing all these experiments. That definitely could be a possibility.
Thank you. With that, we cannot cover any more questions. Thank you so much, Phanam. As always, you're intelligent and intuitive and very empathic presentations. And Giuseppe, thank you for your presentation on the food, energy, and consumption. And Martis devoting his time to a great, vibrant, and very interactive panel discussion moderation. Thank you everyone for your participation today. If you missed this episode, you can watch the recording on SpaceConneX YouTube. So make sure you subscribe. Thank you everyone for being present with us on the weekend, and we hope to see you soon. We'd love to hear your feedback, and see you soon in the next episode. Thank you everyone.
Thanks.
Thank you.